we've got a nice jar of ice here, just sitting there. Would this be endothermic or exothermic? Endo. Very good. Okay, let's try it now. Let's try it now. Will it go through there? Still goes through. Okay. Wait for the water to boil. So what's going to happen here, this is what we call a Japanese, it's a Siphon coffee maker. So we put our water down below, and we're going to heat it up with the alcohol, and it's going to, what's going to happen when it boils?
It's going to go up.
Well, it can't make steam, right, because we got it closed off, a closed system. So it's going to push upward, it's going to come into the upper chamber, and it's going to do work, it's going to mix with the coffee. And then what happens when we pull it away?
It'll cool down.
Yeah, it'll cool down, but what will happen to the water? Well, first of all, it'll probably drop back down because of gravity. But if we take away the heat, what does the second law say? Heat goes from hot to cold, right? So if we take away the heat, now the bottom becomes cold, the top is hot, so where's it going to go? It's going to drop down to the cold, right? Yes. Yeah, go ahead. All right. This might take a minute because I got to heat it up. Let's see if this now goes through. Oh! 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 Show everybody. Here, hold this under your hand. Show everybody. Hold it up so we can see. How come it doesn't go through? Why does it expand? Can somebody else bring an explanation? Why does it expand? Okay, so remember we talked about atoms, right? And when we add heat, they get excited, so they expand out, right? So in the stick that has the sphere on the end, the ball on the end, it's expanding, but did the ring expand? Okay, now take the, okay, you can get it through there now, right? Okay, heat it up again a little bit. He's going to heat it up again. He's going to make it so that it won't expand. We'll just show you how hocus pocus this can be. In fact, would you stand back in here? Because I want everybody to see back there. They can't see. There we go. All right, now try it again. The ring. Okay, now, see how it doesn't go through? Take the ball and stick it in the ice. All the way. All the way. There you go. Pull it down. Now stick it through the ring. Wow. So fast. It happens so fast, right? So, is it possible that our atoms can respond to the heat very quickly? Okay. Now, what happened there when he stuck it in the ice? Was it endothermic or exothermic? Well, I got two different opinions. What do we got? What? The heat went out. And what pulled the heat out? The ice. Because the heat moves from the hot to the cold, right? So it wasn't the cold going to the hot, it was the hot going to the cold. Okay. So that's the thing you got to get in your head, is that when you feel cold outside because of the weather, it's not because you're cold, your heat is escaping. Why? So let me prove it to you. Why do you put on a jacket? To what? To keep the heat in you. Why do you put a blanket on at night? Keep the heat in you. Got it? So it's not because, you know, you're feeling cold, so you want to block the cold. You want to keep your heat in because the cold is endothermic. It's pulling it out of you. Okay, we're getting close now. So pretty soon we'll see if our experiment works. You want to put it in there again?
Are you going to drink it after?
I don't know. We might have to test it. Yeah.
Can I drink it?
Can you drink it? No, I'm sorry. That's not possible.
Why not?
No, because it's caffeine is a stimulant, and I would say it's not good for students. Would you say, Mr. Garcia? Not good for students. But teachers, maybe Mr. Garcia could test. He'll tell you if it was good. Let's see if Mr. Garcia wants that. Okay, who's got the hot packs? Okay, bring them up here. We're gonna boil them up. Well, you did that yesterday, trust. Thank you. Here's the other one. All right, thank you. Okay. So we'll recharge these, and we'll get them going again for our next go around here. Okay. Now try it again. Ah, okay. Now put the ring in there. Just leave the ball out. Put the ring in there. What do you think is going to happen if we hit up the ring? So the ring will expand. The ball should pass through, right? Let's try it. Yeah. Look at how just a little bit of time it expands the material. Okay. I'll put the ring into the ice. All the way in. Here, let's add some water. We'll move it because I don't want to burn my hand. Yeah? I think because the ring has a little bit more surface area on it, so it can gather the heat a little bit faster. Plus, all we have to do is expand the ring just a little bit, right? To have... All right, put the ring in the ring. Now, put it on the ball. Yeah? Think? Ah, finally. Well, be careful. You forced it, that's why. All right, put the ball back in the fire. All right, we're almost at boiling point here. Sorry, guys. I should have started this out and had it going. Sorry, Mr. Good. I wanted to, like, surprise you with the coffee going. I did this when Mr. Schrack was the first year I was here. And he was just so taken by this. He came back the next year.
He just wanted the coffee.
I think that's true. I shared the coffee with him at the top. All right, go ahead, try it. All right, and then back into the water. Ball into the water. Everybody likes that part, right?
Yeah.
All right, now try it again. All right, very good, very good. All right, we're starting to get some thermal expansion. So here's the heat doing the work. And I don't see if you can see the water coming up, and we'll start seeing moving up into the upper chamber here in a second. And as it does, it kind of mixes up with the coffee. And I'm going to tell you guys that in Japan, this was all the rage at one time. You would go to a Siphon coffee bar, okay? And there'd be a bar, just like a regular counter bar, and you'd come in and you'd pay $1 per cup. This is 2 cups worth, so it'd be $2. Okay, it's starting to boil. See it? Starting to boil. And you would get a cup of coffee. This is the way they would make it for you. It's very delicious. And you get to see this whole thing working. When I came back from Japan, I bought 2 of these sets. I brought them back with me. One's a little bit bigger. This is a smaller set. Okay? You see it filling now? Everybody see it filling? One of the great things about Japanese design is nothing is wasted. Nothing is wasted. There it goes, filling up. Yeah, what's your question? No, you may not. Sorry. I'm sorry, I cannot offer that to you.
How about next year?
How about next year? How about Starbucks? Just go to Starbucks and get your coffee. What's wrong with that?
Why would I go over there and buy it with my money when I can come here and get it?
Oh, I see. It's a matter of cost. Okay. Well, I'm sure Starbucks would give it to you if you did something like clean up their parking lot or something like that. You know? Okay. Okay, here we go. Now, when it does happen, it happens very quickly, ladies. Okay. And then I use this high-tech device called a spoon. Oh, it's a fork. And I'll mix it up, make sure it's equally. Yeah, I should use a fork. Huh? See it going? Everybody see? Brittany? Paying attention?
Yes, sir.
Okay, so heat is work. Here's the work. Look at that. That looks good, huh? No, I'm sorry. All right, now I'm going to take away the heat source. Now watch what happens. Heat will move to cold. Heat will move to cold. So if I accelerate this a little bit and I put some cold on it, we should see our coffee start to drop. Now I'm accelerating. Normally it takes a little bit longer than this, but I'm causing it to drop down and feel the cold. So heat moves to cold. This is the proof of it, guys. There's a bigger chunk of ice here. I'm sorry. Can somebody grab that? Amanda? Yeah.
Can you get that?
Where can you buy one? I think the Japanese market still sells it. Push the red button, Amanda.
How much?
I think this is about $80.
What?
And you bought 2? So do I maybe use the restroom?
Yeah, go ahead. All right, does everybody see it? And it pulls it all down. See that? All right. Now, this is the thing about this set. Nothing is wasted. There's no inefficiency. So where did I put this? Oh, right here.
Oh, God.
Oh, wow. Look at how nice that is. Now let's see if the experiment was successful. I'll check right now.
Oh, he's eating something.
I'll check right now. I need to check.
He's got straight.
I don't need to.
He's using it straight. He looks like something on it.
Oh, this is a very good experiment. This was very, very good. This is a great, great example of the first and second law of thermodynamics. Thank you, Mr. Ryan. You're welcome, Mr. Ryan.
What about that coffee?
Mr. Garcia, do you need some example of first and second law of thermodynamics?
I know I do.
Sure.
Okay, great. Let's do that. Let's help you out with that.
He says, look,